This video covers the rest of the lesson 5.2. We've discussed adding and subtracting using algebraic expressions using variables. We discussed using variables involving multiplication. Now we're going to discuss using variables to form expressions involving division. How are we going to divide using variables? If I have a problem, like what it says on page 230 of our textbook, a carton has 6 juice boxes. The boxes are put into 2 equal groups. How many boxes are in each group? You have 6 total, you have 2 groups. How many boxes are in each group? Obviously our operation here is division. Your equation is going to look like this. Simply 6 divided by 2, and you'll find that there are 3 juice boxes in each group. What if I don't tell you how many juice boxes there are, and I just give you a variable to represent the number of juice boxes? What if I tell you a carton has m juice boxes? Now this is what the variable we're working with, the letter m. If the juice boxes are put into 2 equal groups, how many boxes are in each group? What's your algebraic expression going to be? It's simply going to be m divided by 2. You don't know the number. All you're going to do is write your expression, which is m divided by 2. You know that you need to divide your juice boxes into 2 groups. What if I ask you, if they're put into 3 equal groups, how many boxes are in each group? You're just going to take your variable, your juice boxes, which you don't know how many they are. It's represented by m. And instead of dividing by 2, you're going to divide by 3 now, because now you have 3 groups you're talking about. So there are m divided by 3 juice boxes in each group. And another way to write m divided by 2 is the fraction, m over 2. Remember, fractions, the numerator is being divided by the denominator. And another way to write m divided by 3 is m over 3. If you are doing m over 1, if I ask you how many juice boxes are there in one group, and the whole carton is only divided into one group, it's just going to be m over 1. Or in other words, m, because we know that a variable divided by 1 is going to be the variable itself. We know that anything divided by 1 is going to be the number itself. 2 divided by 1 is 2, 5 divided by 1 is 5, and so on. So m divided by 1 is m. Now notice here a similarity between division and multiplication in the way we represent algebraic variables. Remember, we said 1m or 1n, so 1 times n could be represented as n. And now here we're seeing m divided by 1 could be represented as m. So these are very similar, and we know that multiplication and division interrelate. We know that they kind of complement each other. So it makes sense. Does it make sense that m divided by 1 is m and 1 times m is m? It makes absolute sense. So remember that when you see a variable standing alone, it could represent 1 times the variable, or it could represent the variable divided by 1. So in algebra, we would represent m divided by 2 as m over 2, such as we wrote up here. And we would represent m divided by 3 as m over 3, like we wrote here. So the expressions m over 2 and m over 3 are examples of algebraic expressions involving division in terms of m, the letter m. Let's take this table for example. It says a package of m pretzel sticks is to be shared equally among some children. Find the number of pretzel sticks each child gets in terms of m. Then find the number of pretzel sticks for the given values of m. So first it tells you to just take your variable of m and find out what your algebraic expression should be. And then it gives you values for m, and it tells you how many pretzel sticks should each child get when m equals 24 and when m equals 48. When you have one child, number of children, the number of pretzel sticks in each child that each child gets is m. If m equals 24, then each child is just going to get 24. If m equals 48, that one child is going to get 48 pretzel sticks. If you have 3 kids, the number of pretzel sticks each child gets, you're going to represent it as m divided by 3, or m over 3. And then if you pretend that m equals 24, then you're going to do 24 divided by 3. So each of those 3 children is going to get 8 pretzel sticks. And if m equals 48, you're going to do 48 divided by 3. So each of those 3 children is going to get 16 pretzel sticks. If your number of children is 6, you're going to represent the number of pretzel sticks each child gets. You're going to represent it as m divided by 6. And then what if m equals 24? So you're going to do 24 divided by 6. And you're going to do 48 divided by 6. If the number of children you have are 8, you're going to do m divided by 8. Then you're going to pretend m is worth 24. You're going to do 24 divided by 8 and 48 divided by 8 and so on. Let's do a couple more examples which will include information from the past video, the first part of lesson 5.2. If we have 2 children and we're given their present ages, now for the first child, their age is 5t. That doesn't really tell you how old they are now, but the question doesn't really ask you how old is this child. It's just asking you, write the expression for their age 4 years ago, 3 years from now, and 10 years from now. You would take whatever variable or information they give you or whatever they give you for their present age and include it in your expression, in your algebraic expression. Although 5t doesn't really make sense to us, that's not what the question is asking us. All we're responsible here for is to write an expression. It gives you the example of, if their present age is 5t, to represent their age 4 years ago, all you have to do is 5t minus 4. To represent their age 3 years from now, you're going to do 5t plus 3. Now we're adding because we're going forward in time. So 3 years from now, they're going to be 5t plus 3. 10 years from now, they're going to be 5t plus 10. Now Elijah is now 10u. 4 years ago, you should probably say, he was 10u minus 4. And so on, just like we did with the other child. It's going to be 10u plus 3 and 10u plus 10 for 3 years from now and their age for 10 years from now. Now we have a table that asks us both multiplication and division questions. If x is 3 and x is 15, what does 4x equal to? So our first example is 4x. If x is 3, it's just going to be 4 times x, which is 4 times 3. And here you would write 12. If x is 15, it would just be 4 times 15. So x, 4 times x, 4 times 15. And you would have to calculate for that answer. X divided by 3, what if x is 3? You would do 3 divided by 3. And what if x is 15? You would do 15 divided by 3. What if x is 3 when you have 3x minus 5? If I have 3x minus 5, that means I'm multiplying 3 times x, which means here we're doing 3 times 3 minus 5. Whatever you get here, that's your answer. So 3 times 3, 9, minus 5, 4. This is what you should get. What if x is 15? You would do 3 times 15, whatever you get here, minus 5. What if 5x divided by 6? I have 5x divided by 6. Here I'm doing multiplication and division. I'm multiplying 5 times x, so I'm going to do 5 times 3 and take all of that and divide it by 6. And then I'm going to do 5 times 15 here and take all of that and divide it by 6. 20 minus x divided by 2. I'm going to do 20 minus x. Here x is 3, so 20 minus 3. All of that, my answer, divided by 2. Then I'm going to take 20 minus 15, whatever I get here, divided by 2. And that's what I would do. Now here you would actually have to write your answers. I just told you the equations so you could know what you need to do in this case when you're given these kinds of problems. What does it mean when you have 3x minus 5? 3x is just 3 times x. So you take your values of x here, which are 3 and 15, and you would solve for that. So in this table, you would have to actually write the answer. If you write the answer in the equation, that would be even better because then I could see your thought process. What expression did you even use to get to this answer? And if you have wrong answers, you will see what went wrong within your expressions. So if you wrote your equation wrong and you got the wrong answer, you would be able to go back and find out what you did wrong exactly. Whereas if you neglect to write down your equation, you would have no idea what went wrong there, and you would not remember the way you were thinking, you would not remember why you wrote that answer. I wouldn't know where you went wrong, so I wouldn't be able to help you. So always the best thing to do in math, it's just a golden rule, it's just going to be a rule wherever you go in math for the rest of your life, show your work so you could know what you did wrong and your teachers could know what you did wrong.